What is a carbohydrate?
Organic compounds of carbon, hydrogen, and water. Typically with hydrogen and oxygen in a 2:1 ratio, respectively, these are often called sugars.
What is a noble gas core?
Used to abbreviate an atom's electron configuration, e.g., the electron configuration of nitrogen is 1s22s22p3, which can be abbreviated He2s22p3.
How many stars are in our galaxy?
Astronomers currently believe that our galaxy, the Milky Way, contains between 200 billion and 400 billion stars.
Do polymers have stereochemistry like small molecules?
Yes. The most common example is polypropylene. This polymer has a methyl group attached to the backbone of the polymer. If the methyl groups are all on the same side of the chain, the stereochemistry is known as isotactic, top structure below. If the arrangement of the methyl groups alternates which side of the chain it's on, the polymer is called syndiotactic, bottom structure below. If there's no order at all to the substituents, we call the polymer atactic.
What is a surfactant?
Surfactants are molecules that reduce the surface tension of a liquid. These are typically amphiphilic organic molecules, which means that they have one hydrophobic and one hydrophilic section. This will cause them to align in a certain way at the surface of a liquid, which interrupts the order of the liquid at the surface, lowering the surface tension.
Why do shrimp change color when they're cooked?
Some, but not all shrimp, are grayish when they are raw, but turn pink once they're cooked. It makes sense to guess that this is because some chemical compound with a red color is being produced once you add heat. What's actually happening, though, is that the more intense pigments in the shrimp's shell are decomposing with heat, while the compound responsible for the red color is more stable. That red molecule is called astaxanthin. And it's not only found in shrimp shells but is also the reason that salmon meat is red. You'll probably be interested to know that there are a good number of chemistry experiments that you can perform right in your own home. While we can't teach every principle in this book with experiments that you can do with household items, we will do our best to illustrate some of the basic principles. Mostly those relevant to basic chemistry lab work, with items you may already have in your kitchen.
What pollutants are introduced into the atmosphere by volcanoes?
Volcanoes are a major source of sulfur dioxide, SO2, gas in the atmosphere. This gas is poisonous and is an irritant to the mucous membranes found in your throat, eyes, and nose. Sulfur dioxide also reacts with oxygen, sunlight, dust, and water to create SO2 droplets and sulfuric acid, H2SO4, which leads to a type of smog referred to as volcanic smog, or VOG. VOG can cause asthma attacks and damage the upper respiratory tract. The sulfuric acid produced can also cause acid rain.
What is a crystal?
A solid with an ordered arrangement of atoms of molecules.
So how then do astrochemists detect H2 in space?
By looking at other parts of the electromagnetic spectrum. Chemists can detect molecules with no net dipole like H2, detected by UV radiation, or CH4, detected by IR.
Why did Karl Bosch, Germany, and Friedrich Bergius, Germany, win the Nobel Prize for Chemistry?
For their contributions to the invention and development of chemical high-pressure methods. Bosch worked with Fritz Haber on the synthesis of ammonia that today bears both their names, but was not recognized in the 1918 prize with Haber. Bergius developed a process for producing liquid hydrocarbon fuel from coal. Bosch also worked on the so-called Bergius process. After Bergius sold his patents to BASF, where Bosch was working at the time. The Bergius process and the Haber-Bosch process both operate at high pressures, and both methods had significant impacts on human history.
What makes leaves change color in the fall?
Leaves are normally green because of chlorophyll. Chlorophyll absorbs blue and red wavelengths of light, so it appears green. This molecule is crucial for photosynthesis, but when the days begin to get shorter as winter approaches, plants begin to produce less chlorophyll. As the level of this green chemical in leaves falls, we can start to see other highly colored molecules. In particular, carotenoids, which appear yellow, orange, or brown, start to become visible. These molecules are always present in the leaves. It's just that the green color of chlorophyll dominates most of the year.
What is the main group elements?
Elements of the S and P blocks in the periodic table.
What is specific heat?
The quantity of heat energy needed to increase the temperature of a substance by a fixed amount.
What is the basic structure of an amino acid?
The basic structure of an amino acid is shown below. Each amino acid has an amine, NH2, group, a central carbon atom known as the alpha carbon, a side chain, denoted R, and a carboxylic acid, COOH, group. The amine groups and carboxylic acid groups of amino acids can be joined in a chain to form polymers of amino acids, known as peptides. Two amino acids form a dipeptide, three form a tripeptide. And chains of 4 or more amino acids are commonly referred to as polypeptides. Long polypeptides fold into specific conformations, which is what makes up a protein.
How is information encoded in RNA and DNA?
The sequence of nucleotides in DNA can be read only by first separating the DNA double helix, performed by the enzyme helicase. The information is read by RNA polymerase, which then transcribes a corresponding piece of RNA. If the purpose of the RNA is to encode a protein, it can then be read by a structure called a ribosome, which creates proteins according to the specific ordering of the nucleotides in the RNA strand. The ordering of the nucleotides in DNA, and thus the nucleosides in RNA, is extremely important in determining the function of a protein. Nucleotides are read in groups of 3. These groups of 3 are called codons, and each codon tells the ribosome to incorporate a specific amino acid into the peptide/protein it creates. There are also specific codons that tell the ribosome to start or stop creating a peptide. Any mistake in the copying of DNA or RNA can potentially lead to major problems. So it's important that the cellular machinery that carries out these processes is extremely accurate.
Why does drinking alcohol make people loopy?
Alcohol, specifically ethanol, CH3CH2O, is a mild depressant that affects your central nervous system. The specific biological effects are pretty complicated. Some systems are enhanced by ethanol. Others are inhibited. This combination of effects is why drinking can relax your muscles but also make you more animated. It may seem that alcohol lowers your inhibitions, but some experiments suggest this is a psychological effect and not a chemical one.
What is a substitution reaction?
The exchange of one functional group, or atom, for another is called a substitution reaction. The transesterification reaction above is an example of substituting AOC2CH3 group for AOC3 group.
Do reactions always take place at the metal center of an organometallic complex?
Not always. Reactions can also take place at the ligands of a complex. For example, a nucleophile can add to an alkene ligand while it is coordinated to a metal center.
What is the rate constant for a reaction?
The rate constant for a chemical reaction is a quantity that describes how rapidly the reaction proceeds. Rate constants can have different units, depending on how many molecules are involved in the reaction. Consider a simple reaction where a single molecule of a species A becomes a molecule of species B. The rate of the reaction will depend on the concentration of species A, denoted A, present, and the rate constant, K, for this reaction. The rate equation for this reaction would be reaction rate equals Ka. This tells us that the reaction rate depends only on the concentration of A, and that the reaction rate will increase as the concentration of A is increased. In truth, the reaction rate also depends on the temperature, pressure, and perhaps other factors as well, but these are all bundled into the rate constant, K.
What is combustion?
A chemical reaction between a fuel and an oxidant to produce heat.
What is HDPE, high-density polyethylene?
High-density polyethylene is technically any polyethylene with a density of 0.93 to 0.97 g/cm3. The density in polyethylene is controlled mostly by the number of branch points along the polymer chain. HDPE has very few branches, so the chains can stack together very closely. This tight packing makes it a very strong polymer. So it's used to make things like bottle caps, milk jugs, and hula hoops.
How does pectin gel make jelly?
Pectin is a polysaccharide from the cell walls of plants that helps plant cells to grow and also to stick to their neighbors. Commercially, pectin is extracted mostly from citrus peels, but other plants are also used. Pectin is the gelling agent that helps jams and jellies to set, giving them a consistency that is useful for spreading on toast. It does this using a very similar mechanism as the one it uses to keep plant cells together. The chains of sugar molecules, polysaccharides, can form bond between strands, creating an elastic network known as a gel, or jelly.
How does an atomic bomb work?
Atomic bombs, A-bombs, are based on nuclear chain reactions that occur very rapidly, causing a huge release of energy in a very short amount of time. In early designs, two pieces of uranium would be fired at one another in the core of the bomb, initiating the fission chain reaction responsible for the explosion of the bomb. As the bomb starts to detonate, the core of the bomb expands, and it is necessary that pressure be applied against the expanding core while the fission process takes place. Within a fraction of a second after detonation, the explosion takes place. These are the type of bombs that were used at Hiroshima and Nagasaki in World War II and are the only nuclear weapons that have been used in war to this day.
Why did Lars Onsager, United States, win the Nobel Prize for Chemistry?
For the discovery of the reciprocal relations bearing his name, which are fundamental for the thermodynamics of irreversible processes. Onsager received the prize for his brilliant mathematical work that allowed for a theoretical description of irreversible processes. He additionally made a large number of other contributions to physics and chemistry during his career, including developments surrounding the conductivity of solutions and flow of electrolytes, and a solution to the Ising model.
What is malleable?
A material that can be pressed into shapes or sheets without breaking or cracking.
What is a Gaussian distribution?
A Gaussian distribution is a type of probability distribution that characterizes the distribution of a randomly distributed variable about a single mean, average, value. This is the most commonly encountered type of distribution in statistical analysis, so it is good to be at least a little familiar with it.
How did ancient civilizations make bronze?
Tin had to be mined in the form of an ore and then purified through a process called smelting. Once the tin was pure, it could be added to molten copper. In whatever ratio was desired, to make bronze for use in things like tools and weapons.
How is the presence of illegal narcotics identified?
Analytical chemists have developed simple chemical tests that can identify the presence of illegal drugs within seconds. Law enforcement officers routinely use these when they are unsure whether someone is in possession of an illegal narcotic. A common field test for cocaine, for example, uses a cobalt thiocyanate complex that turns blue in the presence of cocaine.
What is a quantum number?
Values of conserved quantities in a quantum mechanical system. Electrons are described using four quantum numbers, n, the principal quantum number, L. The azimuthal quantum number, ml, the magnetic quantum number, and ms, the spin quantum number.
What are some different types of titrations?
We already considered the titration of a base by an acid. Certainly acids can also be titrated by bases. But there are also many other types of titrations, so let's look at just two more. Complexometric titrations. This type of titration involves using a titrant that forms a complex with the analyte. In this case, the species of unknown concentration is often a metal ion. And the indicator may be a dye molecule that forms a weak complex with the metal ions. The indicator ion complex is bound more weakly than the titrant ion complex, such that the titrant can displace the indicator from the metal ions. Thus, when the titrant has bound to a significant fraction of analyte molecules, the indicator molecules are displaced and the solution will change color. Redox titrations. A redox titration is a titration that involves the use of a reducing agent or an oxidizing agent to determine the concentration of the unknown species. In this case, the indicator can again be sensitive to the presence of excess titrant, giving a color change when the titrant becomes present in excess.
What is thermite?
Thermite is a mixture of a metal powder and a metal oxide that is capable of causing a very strong exothermic reaction. Different metals can be used, but the most common mixture is iron oxide, Fe2O3, and aluminum, Al, powder. The mixture is stable at room temperature, but when it is ignited, it burns in an incredibly exothermic reaction, releasing a lot of heat.
What is an element?
Atoms with the same atomic number.
What is a chemical bond?
Sharing of electrons between two or more atoms.
Why did Victor Grignard, France, win the Nobel Prize for Chemistry?
For the discovery of the Grignard reagent and Paul Sabatier, France. For his method of hydrogenating organic compounds in the presence of finely disintegrated metals. Grignard was recognized for his preparation and study of organic magnesium compounds. RMGX, which he prepared from organic halides, RX, and magnesium metal. He discovered that these magnesium reagents can react with carbonyl groups to form new carbon-carbon bonds. Sabatier shared the prize in 1912 with Grignard for his work on hydrogenation, or the addition of a molecule of H2 to an organic molecule. Sabatier observed that nickel acted as a catalyst for these reactions. The Sabatier process, the reaction of CO2 and H2 to form CH4 and H2O, continues to be a useful reaction. And NASA is investigating it as a means to generate water from CO2 waste, from exhaling astronauts.
What is a salt?
An ionic compound that can be thought of to form from the neutralization of an acid or base.
What are alternative solvents?
Alternative solvents are relatively environmentally benign solvents that can be substituted for the more hazardous choices, which, while they may be traditionally used, may have established precedents without environmental safety or toxicity concerns in mind. One such example is 2-methyl tetrahydrofuran. As a solvent, it possesses similar characteristics to the widely used dichloromethane and tetrahydrofuran solvents, but with significant environmental advantages in that it is produced from renewable feedstocks, like corn cobs and bagasse, and is easier to separate and clean up. You can compare the chemical structures of 2-methyl tetrahydrofuran. Left, with dichloromethane, center, and tetrahydrofuran, right, below.
What is a dependent variable?
A variable that changes as a function of the independent variable.
What is magnetic levitation?
Magnets apply forces on one another, and these forces can be either attractive or repulsive. If they are repulsive, and if the forces balance against the force of gravity in a carefully designed way, then the magnetic forces can be used to make an object levitate. This is put to practical use in high-speed trains, which can hover above the track while moving quickly on a magnetic cushion.
Why did Gerhard Ertl, Germany, win the Nobel Prize for Chemistry?
For his studies of chemical processes on solid surfaces. Surface chemistry is a topic of broad importance to many applied areas of chemistry. These include atmospheric chemistry, as some atmospherically relevant reactions take place at the surface of ice crystals, semiconductors, and solar energy capture, to name a few. Ertl was one of the founding fathers of modern surface science, and he played a role in developing many of the techniques used to study surfaces today. The study of well-characterized surfaces typically requires studies to be carried out under ultra-high vacuum conditions so as to avoid contamination of the surface. To be studied by any gas phase molecules that may tend to adsorb onto the surface.
What are the wavelength and frequency of light?
The light we see is a form of energy called electromagnetic radiation. It may sound like something complicated, but it's nothing too exotic or unfamiliar. Everything you see is because of electromagnetic radiation. Electromagnetic radiation consists of perpendicular electric and magnetic fields that oscillate in amplitude. The number of times per second that the fields oscillate is the frequency of the radiation. This is measured in hertz, or inverse seconds. The wavelength is the distance that the light travels through space during one oscillation of the electric or magnetic field.
Lipscomb, United States, win the Nobel Prize for Chemistry?
For his studies on the structure of borans illuminating problems of chemical bonding. Boron hydride, borane, complexes participate in many interesting examples of chemical bonding. And this is due to the fact that boron possesses one less electron than carbon to donate to chemical bonds, but still often forms four coordinate complexes. Lipscomb won the prize for his pioneering explorations of the chemistry and bonding in borane complexes using X-ray diffraction and quantum chemical calculations. He reached a level of understanding of borane complexes at which he could predict the properties and reactivity of borane complexes reasonably well. And his work led to deeper insight into the nature of the chemical bond.
Are only small main group elements detectable by NMR?
The list of nuclei in the previous question are just commonly used ones in NMR experiments. Other elements are observable, but sometimes these require special hardware to obtain useful signal levels.
What is a chemical signaling molecule?
Chemical signaling molecules are small molecules that act to carry a message in a biological system. A cell can secrete signaling molecules and allow them to diffuse through the bloodstream. Signaling molecules can also be stuck to the surfaces of cells. It would be impossible to give a comprehensive description. So we'll just mention a couple of examples of chemical signaling. Apoptosis, which is the intentional death of a cell, is a process that involves chemical signaling. An external signal reaches the cell, which sets off a series of reactions inside the cell, ultimately leading to its death. Calcium ions are another species often involved in cell signaling as their concentration affects the activity of many proteins and is also important for telling cells when to reproduce. Hormones are another type of chemical signals. They travel through our bodies, controlling growth of muscles and tissue, our reproductive systems, and our metabolism, among other things. These examples are just a small sample of the huge number of processes controlled by chemical signaling.
What is a nucleoside?
A biochemical molecule consisting of a nucleobase and a sugar molecule.
How is nuclear chemistry different than other types of chemistry?
As the name implies, nuclear chemistry deals specifically with chemical events involving the nucleus itself. While most other areas of chemistry involve rearrangements of the electrons, nuclear chemistry is focused on radioactivity and the properties of nuclei, and it finds some of its most important applications in energy production, weapons, and medicine.
What makes my cooking pans non-stick?
Heat coating that is placed on cookware is usually polytetrafluoroethylene. PTFE, marketed as Teflon, R, by DuPont, R. The strength of the CF bond, and its reluctance to interact with just about anything else, makes Teflon, R, very heat-resistant and slippery stuff. Aside from coating cookware, it's used to make gears and bearings. And it's a key component of Gore-Tex, the material your waterproof jacket is made of.
What keeps an electron from crashing into the nucleus?
Opposites attract, so electrons and protons are attracted to each other, making it somewhat difficult to understand why an electron wouldn't just get as close as possible to the nucleus and crash into it. The key to answering this question has to do with the fact that electrons are very small particles, so they are governed by rules that don't apply to larger objects. As we've talked about a little already, electrons are best thought of as clouds of negative charge surrounding the nucleus. Their properties are governed by rules that describe the cloud as a whole, rather than as a single particle. It turns out that there is something favorable about the electron being spread out, or delocalized, around the nucleus. For reasons we won't go into in detail, when the electron's cloud gets packed closer to the nucleus, the energy associated with its motion, its kinetic energy, begins to rise, which makes the situation unstable. There's a balance between the stability associated with placing the electron close to the nucleus, the favorable positive-negative charge attraction, and that associated with spreading out the electron's cloud, to keep its kinetic energy low. This prevents the electron's cloud from getting too close to the nucleus or the electron just crashing into the nucleus.
What is heat?
Heat is responsible for all types of energy transfer, other than those that fall under the definition of work. One easy example to think about is ice cream melting on a hot day. Because the ice cream is at a lower temperature than its surroundings, heat flows from the surroundings to the ice cream, causing its temperature to increase, and eventually it melts. There are lots of other examples of heat flow too. It's a pretty big category since it covers all types of energy transfer that aren't defined as work.
What was Agent Orange?
Agent Orange was an herbicide consisting of a mixture of 2,4-dichlorophenoxyacetic acid and 2,4,5-trichlorophenoxyacetic acid used by the U.S. military during the Vietnam War. The intent was to defoliate rural areas of the country, thus removing strategic ground cover and food sources from the rural areas. It was also discovered that the 2,4,5-trichlorophenoxyacetic acid was contaminated with 2,3,7,8 tetrachlorodibenzodioxin, which is an extremely toxic chemical. Agent Orange was sprayed throughout rural areas of southern Vietnam at high concentrations. An average concentration of 13 times what was recommended by the USDA for domestic use, resulting in roughly 20% of southern Vietnam's forests being sprayed. The use of the Agent Orange herbicide resulted in extremely negative health effects for people in these areas. and the effects still persist today despite the Vietnam War having ended in 1975. It is estimated that 1 million people are currently disabled or suffer major health problems as a result of the use of Agent Orange.
What is the structure of diamond?
Diamond has a repeating structure of carbon atoms in which all the atoms are bonded to 4 others in a tetrahedral geometry. It's easiest to see if we first look at the structure of cyclohexane. A ring, cyclo, of 6 carbon atoms, hex, with no double bonds, on a. If we repeat the structure of cyclohexane over and over, we arrive at the structure for diamond.
How does the density of matter in outer space compare with that in Earth's atmosphere?
To give a quantitative idea of just how dilute the matter in outer space is, consider that roughly 2.5 x 1019 particles, typically atoms, occupy 1 cubic centimeter, 1 ml, of volume in the Earth's atmosphere. In outer space there is, on average, only one single particle in this same volume. Outer space is a much better vacuum than even the best vacuums ever created on Earth.
Why do polymorphs matter?
Different crystalline polymorphs will have different material properties and physical properties. In medicine, for example, the body may absorb some polymorphs of a drug more readily, making them more potent or more effective. Polymorphism can also change the fundamental physical properties of a material, affecting things like its conductivity and thermal stability.
What is a formal charge?
The amount of charge, typically in integer units of electron charge, assigned to a specific atom in a molecule.
What is hydrolysis?
The breaking of chemical bond, S, by the addition of water to a molecule.
What is an extensive property?
A property that depends on the amount of a substance present, e.g., size, mass, volume.
What is precipitation?
Precipitation is the formation of a solid in a solution. This happens when a substance has too low of a solubility to remain dissolved in the solution. This process can occur for a variety of reasons, such as when a new product of a chemical reaction has low solubility or when a temperature change takes place. Precipitation begins when a small crystal begins to form, which is part of a process called nucleation.
What is the difference between eukaryotes and prokaryotes?
Prokaryotes are organisms whose cells do not have a nucleus, while eukaryotes are organisms whose cells do have a nucleus. Prokaryotes are most often, but not exclusively, unicellular, single-celled organisms. In addition to lacking a nucleus, they also lack other separate membrane-bound organelles. All of the proteins, DNA, and other molecules in a prokaryotic cell float around within the cell membrane but are not separated into different compartments. Eukaryotes do typically have separate membrane-bound organelles within their cells. They may be single-celled or multicellular organisms. Every large organism, animals, plants, fungi, is eukaryotic, and many small and single-celled organisms are in this category as well.
What is a melting point?
The melting point is the temperature at which a substance changes from the solid state to the liquid state. At this exact temperature, the two phases are in equilibrium. So fractions of the sample are constantly moving between the two phases of matter. In practice, it is pretty difficult to observe the exact melting point of a substance.
Are chemists still looking for new reactions?
Yes. Chemistry has hundreds of years of knowledge to build on, but it is in no way a complete field. New ways of making existing molecules, and making chemical structures that are completely new to our planet, are absolutely goals of modern chemistry. Developing new chemical reactions, and understanding old ones, are topics of eternal interest to chemists.
What is Gibbs free energy?
Gibbs free energy is a quantity that describes the amount of useful work. See physical and theoretical chemistry, that can be obtained from a system at a constant temperature and pressure. In the context of chemical reactions, changes in Gibbs free energy will typically dictate whether or not a reaction is favorable.
What is the stoichiometry of a reaction?
The stoichiometry of a reaction is closely tied to the idea of the conservation of matter. It tells us the ratio in which the molecules react. Again, using the example at the beginning of this chapter, the reaction stoichiometry 1:2:1. 2 describes the ratio in which methane and oxygen react to form carbon dioxide and water.
What is silicone? Is that the same as silicon?
Silicon is an element, while silicone is a polymer with a backbone of silicon and oxygen atoms. These polymers are very resistant to heat and have a rubbery feel. The latest squishy cookware and bakeware is made out of silicone.
What is a nucleophile?
A molecule that donates an electron pair, i.e., a Lewis base, to an electrophile, i.e., a Lewis acid, forming a bond.
What is the parietal lobe for?
Your parietal lobe controls your speech, visual perception, pain, and touch perception. Spatial orientation, like knowing what direction is up, and other cognitive processes. As you can probably tell by now, there is some degree of overlap between the broad types of functions carried out by different parts of the brain.
How can I make a chicken bone flexible?
Chemistry principles encountered in this experiment: solubility in weak acids. Materials you'll need: a jar vinegar, enough to fill the jar, a chicken bone. One from a drumstick works best. The procedure: obtain a chicken bone, and clean it well. Rinse it with water and remove any remaining skin or meat from the bone. Before you soften the bone, try bending it to make sure it is rigid. Don't break it, but test that it is indeed hard. Fill up the jar with vinegar, and drop your clean bone inside. Cover the jar, just so that your whole house doesn't start smelling like vinegar. And let it sit for about 3 days. Recall that vinegar is a dilute aqueous solution of acetic acid, which is a weak acid. Over a few days, the acetic acid helps to dissolve the calcium in the chicken bone. Since the calcium plays a key role in keeping bones hard, the bone will soften once the calcium is dissolved. Remove the bone, rinse it off with water, and now try bending it again. It should be noticeably more flexible than before. Now you can see that without enough calcium, your bones will not stay strong. This might also provide a good indication of why it's a good idea to brush your teeth. If you leave behind any foods capable of dissolving calcium still on your teeth, Your teeth may lose some of their calcium and begin to become weak.
What is a neutron?
An unchanged arged, subatomic particle found in the nucleus of an atom.
Why did Manfred Eigen, Federal Republic of Germany, Ronald George Rayford Norrish, United Kingdom, and George Porter, United Kingdom, win the Nobel Prize for Chemistry?
For their studies of extremely fast chemical reactions effected by disturbing the equilibrium by means of very short pulses of energy. Norrish and Porter were credited with the prize for their development of flash photolysis methods, which applied short pulses of light to initiate photochemical reactions, allowing them to study very fast chemical reactions that could not previously be observed. Eigen's work differed in that he used sound as his form of energy to probe the chemical reactions, which is far less invasive of an approach in the sense that sound does not cause drastic changes in the behavior of the molecules being studied. Of the two methods, the flash photolysis method is much more akin to the modern spectroscopic approaches used today, while sound-based approaches did not gain as much traction.
What is the Warner Babcock Institute for Green Chemistry?
The Warner Babcock Institute for Green Chemistry was founded by John Warner and Jim Babcock to promote the development of environmentally safe and sustainable technologies. The institute offers training in the principles of green chemistry for both scientists and non-scientists alike. Hydrogen peroxide is an ideal green reagent, including the fact that it is relatively inexpensive and is produced in mass quantities. In fact, 2.4 million metric tons of hydrogen peroxide are produced each year. One matter of concern is that high concentrations of hydrogen peroxide can be dangerous. So reactions should be run at concentrations of less than about 60% H2O2.
What is a nucleic acid?
General term for RNA and DNA, composed of nucleotides, which are in turn each composed of a sugar, a phosphate group, and a nucleobase.
Are there plasmas in our daily lives?
Plasmas are found in fluorescent lights and neon lights. If you've ever seen a Tesla coil at a science museum, the arcs of light that they produce are plasma, as is lightning. Plasma TVs and plasma lamps are correctly named, both generate light using plasma, similar to fluorescent lights.
Can carbon chains form rings, too?
Yes, chains of carbon atoms can connect back to themselves, forming rings of atoms. The prefix cyclo is added to the name of the linear carbon chain to indicate that a ring is present, so hexane becomes cyclohexane. The chemistry ring structures can be different than their linear cousins because of the added energy that some rings contain. We know that sp3 hybridized atoms like to form bonds that are separated by 109.5 degrees. The more that a ring forces those bonds to deviate from that ideal angle, the more energy, called ring strain, that is released when that ring is opened during a chemical reaction.
How can I test the hardness of objects around my house?
Chemistry principles encountered in this experiment: hardness materials, science materials you'll need. Collect several materials of known hardness. Examples include, numbers are based on the Mohs scale. Fingernail, 2.5, penny, 3, glass, typically 5.5 to 6.5, quartz, 7, steel, typically 6.5 to 7.5, sapphire. 9. You can also look for additional items from the list provided at the end of this experiment, or search online for additional objects that have been ranked on Mohs scale of hardness. Of course, you can also choose item of unknown hardness and determine their hardness in this experiment. The procedure: locate a specimen whose hardness you want to test. Note that you will be attempting to scratch the object, so don't choose anything too valuable or anything you don't want scratched. Select an object of known hardness from those you gathered, and try to scratch the surface of your sample by pressing it with the tip or edge of the object of known hardness. For example, let's say you wanted to test a piece of wood. You could try to scratch it with a piece of quartz by pressing the edge of the quartz into the wood. Inspect your sample to see if you have made a scratch in it. You may need to feel the surface of the object with your finger to check thoroughly. If your object was softer than the sample of known hardness, there will be a scratch. If it was harder, then there will not be a scratch. Repeat the test a couple of times to verify the result. Continue performing the scratch test with various objects of known hardness, until you find two adjacent objects on your list, such as a fingernail, 2.5, and a penny, 3, in between which the hardness of your sample rests. You will know you've found this pair of objects on your list when the harder object of the pair does scratch your sample, while the softer one does not. Once you have found this place on the list, you can assert that the hardness of your unknown must lie between that of the two objects of known hardness on the list. For example, if a penny, 3, scratches your object, and a fingernail, 2.5, does not, your object must have a hardness between 2.5 and 3. Additional Mohs hardness rankings: talc, 1, gypsum, 2, calcite. 3. Fluorite, 4. Platinum or iron, 4.5, apatite, 5. Orthoclase, 6. Quartz, 7. Garnet, 7. Hardened steel, topaz, emerald, 8. Corundum, 9. Diamond, 10.
How does my ADHD medication work?
Ritalin, R, methylphenidate, is probably the most common drug for the treatment of ADHD. Attention deficit hyperactivity disorder. Ritalin, R, is a stimulant, increasing the levels of dopamine in your brain. Your brain normally releases dopamine to communicate feelings of pleasure and to increase the rate at which your neurons fire, which is supposed to help you focus.
What are the different groupings for elements on the periodic table?
There are several ways of classifying the elements on the periodic table. One is by the periods, or the horizontal rows, in each of which the properties of the elements change going from left to right. Another common classification is by groups, or vertical columns on the table. All elements in the same group are expected to have similar properties. Which is the periodic property, originally noted in the law of the octaves, after which the table is named. Yet another classification is by blocks, meaning the elements are classified by the type of orbital in which the highest energy electrons reside, see below. The logic behind this type of classification is that the type of orbital in which the highest energy electron resides strongly influences the reactivity of the element. Thus elements in the same block usually have similar properties. There are even more ways still of clustering the elements on the table. But these three are the most commonly used.
What is titration?
The process of measuring the concentration of an analyte by reacting a second solution of known concentration to cause a reaction.
Can wearing a copper bracelet help with the symptoms of arthritis?
Arthritis is caused by deterioration of the cartilage in a person's joints. Where deterioration happens faster than the body is able to repair it. Copper bracelets are sold based on the idea that a person may have a copper deficiency that leads to the pain in their joints, thus implying that copper from the bracelet could be absorbed through the skin to help correct the deficiency. In fact, copper deficiencies are extremely rare, and most people eat plenty of copper in their regular diet. Rarely are additional copper supplements necessary. It has not been proven that copper can be absorbed through the skin. nor has it been proven that the bracelets can help with any symptoms of arthritis or joint pain. Moreover, excess intake of copper can result in poisoning. So if copper can be absorbed through the skin from a bracelet, one would want to monitor their dosage carefully. It is also worth pointing out that we know of no cases of poisoning resulting from wearing copper bracelets.
What is radio astronomy?
Radio astronomers study what's going on in outer space by using radio waves, as opposed to telescopes, which use light in the visible region of the spectrum. This approach has some distinct advantages, perhaps the most obvious being that radio astronomers can work at any time of the day, while astronomers who rely on light telescopes can only work at night. Radio astronomy relies on monitoring weak radio wave signals coming in from outer space, and knowing how to interpret these signals to draw conclusions about the locations of celestial bodies and events that have taken place far, far away.
What is a boiling point?
The technical definition of boiling point is the temperature at which the vapor pressure of the liquid phase equals the pressure of the surrounding gas, atmospheric pressure usually. This is a precise way of saying the temperature at which a liquid turns to vapor.
What is electron microscopy?
An electron microscope is a microscope that uses a beam of electrons to produce an image of a sample, rather than using light like in a standard microscope. There are several ways of obtaining an image, but the original was the transmission electron microscope, TEM, which produces an image by passing an electron beam directly through the sample. Electron microscopes offer a significant advantage in resolution over traditional light microscopes. This is due to the fact that the wavelengths associated with electrons are much shorter than those associated with visible light. It's possible to achieve resolutions of up to roughly 10 million times magnification using electron microscopes, as compared to about 2,000 times magnification in the best light microscopes.
What is a dipole?
A molecule or a property of a molecule that involves the separation of positive charge from negative charge.
Why did Peter, Josephus Wilhelmus Debye, the Netherlands, win the Nobel Prize for Chemistry?
For analyzing molecular structure through his investigations on dipole moments and the diffraction of X-rays and electrons in gases. Debye developed the theory of how electric fields affect molecules, and figured out a method to determine their dipole moments by measuring how their insulating properties and density vary with temperature. He also measured interferences of X-rays and electrons with molecules in the gas phase, along with other investigations into molecular structure, to determine the chemical structures of molecules. This work provided some of the first detailed structural characterization that allowed chemists to definitively determine the different structures of isomers, compounds of the same chemical composition but different geometrical arrangements of the atoms.
What is progesterone?
Progesterone is a steroid hormone that is crucial to regulating the female menstrual cycle and pregnancy cycle in human females and in some other species as well. It is produced in the ovaries and the adrenal glands and is stored in fat tissue.
What are hydrocarbons, and how many different ones are there?
Hydrocarbons, as you might have figured out from the name, are molecules that contain only hydrogen and carbon atoms. There are literally an infinite number of ways to arrange these two elements together, especially if you include polymers. See polymer chemistry. Hydrocarbons are important molecules. Different sizes and types of hydrocarbons are known as natural gas, gasoline, waxes, like candles, and plastics.
What does it mean when we say a chemical reaction takes 1 minute?
When we say a reaction takes 1 minute, what we're really saying is that a certain fraction, specifically that fraction is 1-1/e, or about 63%, of the reactant molecules have gone on to form products after 1 minute has passed. E refers to the irrational number E equals 2.7182818. If we say a reaction takes 1 year, or any other amount of time, we're also referring to that same fraction of reactants becoming products. It's not that 100% of the reactants have become products, but rather just a certain fraction.
What is the condensation reaction?
A reaction in which two molecules combine to form one larger molecule, with the concurrent loss of another small molecule like water or HCl.
What is the shape of a carbon-carbon double bond?
The geometry of the carbon atoms in double bonds is planar. This shape comes from the hybridization of the carbon atom, which is sp2, one p orbital is not involved in forming single bonds. To get a bonding interaction between these two remaining p orbitals, they have to overlap in space. So in a molecule like ethylene, C2H4, all of the hydrogen atoms are located in the same plane.